Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on December 30th, 2025, about a week ago. It introduces a robust framework that prevents reward hacking in text-to-image models, achieving a 0.95 score on optical character recognition tasks without the image quality degradation usually seen in standard reinforcement learning. The paper is titled, GARDO, Reinforcing Diffusion Models Without Reward Hacking. And, as we'll see later, the method unlocks some fascinating emerging capabilities for handling complex prompts. For those interested in the implementation, the authors have shared their code on GitHub. To really see what reward hacking looks like in practice, Figure 1 presents a visual comparison using the prompt A storefront with GARDO written on it. Looking at the bottom row, we see results from a standard method called flow GRPO, where an optical character recognition score was used as the reward. Notice how the images are full of severe noise and artifacts. The model effectively hacked the metric to get the letters right, but completely sacrificed visual realism. In contrast, the top row shows the results from GARDO. These images remain photorealistic and diverse, proving that the method can optimize for specific text constraints without destroying the underlying image quality. Figure 2 outlines the full GARDO pipeline designed to solve this. It starts on the left with the policy model generating images from a prompt. These images flow into the reward function, but then the process splits into two critical checks. The top branch features the uncertainty estimation module, which identifies when the reward model is confused or unstable. This acts like a gate, depicted by the valve icon, applying penalties only when necessary. Simultaneously, the bottom branch uses Dino v3 to track visual diversity, reshaping the training signal to reward unique images and prevent mode collapse. To illustrate why this balance is so tricky, Figure 3 runs a simplified 2D experiment. On the far left, the setup displays a pre-trained distribution, while the map below marks high-reward targets with stars. The middle columns reveal the dilemma of standard reinforcement learning. With high regularization, the model stays rigid, but with low regularization, it suffers from mode collapse, converging to a single point. In contrast, the rightmost column shows that GARDO successfully captures all three high-reward clusters, maximizing performance without losing diversity. So, Figure 4 validates this with quantitative results on general eval and OCR tasks. In the line plots, standard regularization, shown in green, learns slowly. However, the red line for GARDO rises sharply, matching the unregularized baseline for a 3 to 4 times gain in sample efficiency. The real story, though, is in the radar charts. While the orange baseline spikes on the proxy metric but collapses elsewhere, the red GARDO polygon stays broad and full. This confirms it improves the specific target without sacrificing diversity or aesthetic quality. Well, while the previous charts visualized the trade-offs, Table 1 explicitly details the numerical performance across both trained and unseen metrics. Focusing on the OCR task section, the standard GRPO method, shown in the second row, achieves a strong 0.93 score on the target. However, scanning right to the unseen tasks columns, its diversity score crashes to roughly 18, indicating severe mode collapse. In contrast, the green highlighted GARDO rows match that high accuracy but keep diversity near 22, effectively preserving the base model's original richness. Alright, Figure 8 gives us a peek under the hood at the training dynamics to explain why this works. On the left, Panel A tracks the gated KL mechanism over time. Notice the dashed blue line. It consistently hovers between 8 and 10%. This confirms that the framework selectively penalizes only a small fraction of uncertain samples, rather than applying a blanket constraint. Moving to Panel B on the right, we see the payoff. The red line for GARDO climbs steadily to a 0.95 proxy reward, leaving the purple baseline, which uses multiple rewards without gating, far behind. Wrapping up, the big takeaway here is that preventing reward hacking doesn't mean we have to stifle the model's creativity. By selectively applying penalties only when uncertain and actively rewarding visual diversity, GARDO allows for aggressive fine-tuning on imperfect proxies without the usual quality collapse. This offers a robust blueprint for safer, more efficient model alignment. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.